This is a smart attack. This is a smart attack. This is smart attack.
Hello and welcome to Art Attack. Wow, what's this? I wonder what these look like when they're put together. I know. Come and have a look at this. Oh wow, look at this. These shapes fit together in something we call a tessellation. The man who is best well known for this sort of work is a man named MC Escher. Let's find out more about him.
MC Escher was born in the Netherlands in 1898. From a young age, Escher knew he wanted to be an artist, and at the start of his career he travelled around Italy, where he was inspired to sketch landscapes and insects. However, after a few years, Escher branched out into a different type of art, which was heavily mathematically based. Even though Escher didn't have any knowledge of mathematics beyond secondary school level, he said he could see and understand the maths visually. But this didn't stop him producing some outstanding pieces of artwork, which involve some complex mathematical concepts. Even today, his artwork is highly valued and still is very captivating.
Escher's art is not only captivating, but clever. One of the main techniques that Escher uses in his smart art is tessellation. To tessellate objects means to put them together with no gaps, like this. Looking at Escher's art, you would think that we could use any shape. But is this strictly true?
When it comes to choosing what single shape to base your tessellation on, your options are more limited than you may think. Instead of thinking of a shape as a starting point, think of a point. A point has 360 degrees of space around it. To leave no gaps, the interior angles of the regular shape that you choose must be an exact divisor of 360. Only 3 shapes have this property: hexagons, equilateral triangles, and squares. They will fit around each point 3, 6 and 4 times respectively.
At this point you might think a pentagon might work. After all, 5 is a factor of 360. Isn't it? Well, yes. That makes the exact angle of this bit here 72 degrees. However, we're after this bit. That is the exterior angle, which is 180, that's 72, which equals 108 degrees. Unfortunately, 108 divided by 360 divided by 108 gives you a remainder there. That remainder means that pentagons cannot tessellate with each other, and is also a fundamental reason why no other shapes can either. Now for something a bit different. I have a set of dice arranged here, and if we take a look at it, it looks like they form an impossible object. But when we move the camera, it becomes clear that we are being tricked. Escher uses the idea of perspective, or camera angle if you like, to create some of those impossible pictures. Certain perspectives make us think that what we are seeing is the impossible made possible, but sometimes his creations are even stranger than that.
This is one of Escher's pictures. It is called the Print Gallery. Now it may look a bit confusing, so let me explain. It portrays a man in a gallery looking at a picture. In this picture, he sees some buildings, and one of those buildings is the gallery, with the same man standing in it. This is known as a self-referential piece, as the man is looking at a picture of himself. But there is also some clever maths behind this work. The image has been enlarged. As you rotate around, each edge magnifies by 4 times. So along all 4 edges, the picture zooms 4 to the power 4, or 256 times. This creates the illusion of the building joining on to its zoomed self. You will also notice a gap in the centre. This is where the image is zoomed so far out, Escher could not draw it accurately. Others have filled in this gap for us to see what it would look like.
Now we've seen some examples of Escher's artwork and how he did it. I wonder if you can guess what shape this is going to make, as it is time for our big smart attack!